My name is Ben, and normally I'm a C Sharp developer, C Sharp slash JavaScript, full stack web developer. And I figured out that, maybe it's time to learn something else. I gave few languages a try, mainly Go. Initially, it was pretty fun, but then it just started to be really boring. So I figured maybe I'll try Nim. I heard few good words about it. And the main things that I'm looking for in a programming language right now is that, maybe I'll write it down in here. But first of all, goals for a programming language at the moment, of course, are, first of all, I wanted to have static types. That's something I'm looking for. That's something I personally like to work with. So that's one of my first requirements. The other requirements is that I want it to be a compiled language. And as compiled language, I don't mean something like C# where we compile it to an intermediate language, just like it's with JavaScript or Python. I mean, with Java or with Python. What I mean is that it compiles straight to an executable. And that's something really important to me because, I'm proficient with C#. It's really good when it comes to large applications, something enterprise. It's pretty fast and it's feature rich. I like it. On the other hand, we have JavaScript, which I enjoyed as well. It has good features, especially when you start going to TypeScript land. But just the fact that I can't have an executable. I mean, in theory, with C# now you can have an executable. With JavaScript, if you create a program with Bun, you can compile it to an executable. But the thing is that it's being shipped with its own runtime. So your code is basically, instead of being, 150 kilobytes, it's suddenly 20 megabytes, 50 megabytes, 200 megabytes. Depending if you have a lot of dependencies, then might grow that large. And because of that, it's just, I don't know, not good for my use case. I have like my own home server running a Nomad cluster made of 3 ragtag servers. And because of that, I want to be able to deploy my own applications on that, but I have limited RAM. So it would be nice if my application use as little RAM as possible. If I'll run it with C#, I will be using a lot of RAM. If I'll run it with JavaScript, I'll use even more RAM, just because the application is sitting there while doing nothing. So basically, I'm looking for a way to have the smallest possible Docker container. And yeah, that's my goal. So I want the language to be compiled and require no runtime. So no VMs, no things like that. And the other thing is that I want the language to be relatively simple to use. Because first thing is that, you want I don't want, for example, to deal with something like Rust, where suddenly have really high learning curve. And as far as I tried Rust a few times before, but it was just painful. It wasn't something I enjoyed. Looks like I need to change it. camera battery. Just give me a second. All right, I'm back. So, as I was saying, I'm looking for a language that is relatively simple to use. That's why my first try was to, hey, how about Go? I heard that Go is really simple. And indeed, I was able to pick it up in a weekend and start actually coding some libraries and, testing it out. It was nice and fast. Tooling is amazing. But I'm a kind of programmer that likes to use some features. I don't like when I'm always forced to write for loops, or where, it's just a lot of things that I'm used to with using a language like C# is suddenly more difficult. Maybe not difficult, it's just you need to do a lot of steps to just do this single thing. And I don't like that. Just the fact there's no ternary expression, that was a, kind of turn off for me. So, yep, that's something I didn't like. But then what? What else am I looking for? So I'm basically, static typing, compile language, no runtime, relatively simple to use. And the other thing that I'm looking for is basically some functional programming features. So by that, I mean very simple things. Just being able to have equivalent of map and reduce in JavaScript or filter, and just ability to write functions like that, so that, I can go through a lot of data quickly without basically writing any for loops by myself. I find that kind of code is easy to read, easy to write, and easy to modify too, because you can easily add or remove some steps in between. And I like that kind of style programming. And of course, on C# side, I'm used to things like LINQ, where I have a lot of options to how I can process data. Another thing that I'm always, at least right now, I'm looking for in language is good generics. That was one of my biggest disappointments in Go. I'm somebody that's used to generics. I just use it a lot. I know that's my preference. And I was lucky enough that when I was learning Go, generics was, introduced shortly before that. But oh my, it's limited there. It's coming from C# and TypeScript. It was painful. So that's something I didn't really like, and that's why I'm not continuing with Go right now. So basically, all those requirements. Let's also say that some meta programming would be nice, because why not automate some things? In C#, for example, it can do a lot of stuff through reflection, where you can automatically find types and register things automatically. You know, you can do the magic stuff, things that Go is trying to avoid as much as possible. You can do also a lot of magical stuff in JavaScript. And yeah, basically all that led me to the Nim language. So I believe I should be able to go here. Nim programming language. And that's what I found. So I haven't programmed anything in Nim yet. I skimmed through some tutorials just to have an idea of what is available in the language. And so far I really liked it. And before going into actual learning and seeing, seeing how it's being used, maybe I'll say what is my end goal here. Because, it's one thing like, oh, I'm going to learn a new language and it's going to be Nim. And the other thing is to set some kind of goal for yourself. In my case, I have actual use case for it. So I'm gonna describe it from top to bottom. So for a long time, I wanted to make some kind of like a web application that could also be on mobile, some kind of app that allows me to take various documents and just categorize them. In my case, I'm mostly concerned about being able to keep track of, the tax documents, medical records, all this stuff. So basically, I need to manage different PDFs, and I know maybe JPEGs if I need to take a picture of something, or whatever the format of the document is. I need to be able to manage those, categorize them, maybe tag them, maybe add some dates to them so that I'm reminded, hi, you can throw that receipt out because, your warranty is over or something. And on top of that, the thing is that some of those records, like, your tax records or medical records, you just need to keep as a physical file, at least for some time until it's not needed anymore. So I need to have physical files and, digital files, both categorized in, let's say, the same categories. And, that's what I need for that application. And my goal is to deploy it, on my Nomad cluster. And Nomad is like Kubernetes, but from HashiCorp. And basically, my initial problem with it was that, hey, how am I going to manage those digital files? Because, with physical ones, I actually need to go and touch them, move them around physically. So that's going to be manual. But with those files, I want them to be safe. Therefore, I always need to have a backup of them. In my case, at the very moment, it's, I have a copy on Google Doc that's being synchronized with my NAS, so I have it in two locations. So if something happens with Google Docs, I don't know, they just disappear. I have my physical copy. My copy at my home. If something happens to my NAS, I need to wipe everything. I still have a copy on Google Drive. And I want to keep that system intact. And the thing with solutions like Kubernetes or Nomad is that they are composed of many nodes. Let me go to something like Excalidraw and maybe show it a little bit. So, can I make it dark? Dark theme, please. Yes. So, let's say that I have the Nomad cluster. Okay. Let's name it Nomad cluster. Can I make it larger? Yes. This is a little bit small. Okay. So, when you have a Nomad cluster, it's basically, or Kubernetes or whatever, it's composed of multiple servers. In my simple case, let's say these are 3 servers. So let's just name them quickly. 1, 2, 3, and we have server 1, server 2, and we have server 3. So the thing about Kubernetes or Nomad is that those servers that build the cluster, they are designed to be in some way ephemeral, that nothing should happen if this one suddenly goes away. If this one goes away for a while, nothing happens because whatever was running on it will be moved here and here. It will be redistributed, and when it comes back, it can be put back. There's nothing stopping me from adding some new servers to it and go 5, 7, 9 servers. And all the applications running on them will be redistributed. But in my case, if I have my application running on server 3, okay, let's call it Docs Manager, okay? If I have it running here, that means that all the files for that it manages are here as well. If this server goes away, this will be moved to, I don't know, server 2, for example, or server 1, I don't know. And suddenly all the files that were managed with it aren't there because this is just a Docker container that was, spun up and like, hey, here's your configuration. You should be working. So, that's the first problem. Like, I'm managing files. So then I'm thinking, in theory, you can force it to run on one server. And then when it goes down, oh well, service is down. So that's one option. The other option is like, hey, maybe I can have something outside of my server. And I don't know, let's call this NAS. But this is my NAS. And on my NAS, I will just run, I know, S3 bucket service, some service that provides me that. And then my Docs Manager can connect to it and get data from there. So at that point, if this goes down, your service, can handle it by responding like, hey, your data is unavailable at this moment and whatnot. We can handle it. So I tried in my case to start up S3 or whatever on my NAS, but it's not the most compatible solution. Then is the case of, okay, now you need to have support for that protocol in your programming language and whatnot. There's a lot of that. So I figured like, hey, maybe I'll make my own file management server or something. And I actually came up with a name. I'll call it File API. So the idea is to basically, hey, for the docs manager to be able to manage documents, I'll make some kind of file API, which is a small web service that can basically serve files over HTTPS. Additionally, you can upload files to it. You can browse through directories. You can, I don't know, move, copy, delete. All those basic operations that you can do on your, normal file system, you'll be able to basically do by sending HTTP requests. So not a complicated concept, just something simple. And I actually started working on actual implementation on it. Let me search for it quickly. Okay, so this is basically it. It's on my GitHub, file API, and I actually got some decent amount of pull requests for it on last Oktoberfest. And this is a simple application at that point written in using Bun, because I was like, hey, let's try out Bun. Maybe it'll be faster or smaller than Node.js. And yes, it was. The problem is that it was right before Bun 1.0 was released. And after that, lots of incompatibilities, like, files didn't work, tests didn't work. Basically, lots of problems. So then I went on a search for the programming language that I mentioned before. And I actually started rewriting in Go very recently. And yeah, I got to some place, but at that point I started not liking it, because I'm used to be able to architect things a little bit, and just Go wouldn't let me do that. I needed to keep things a little bit too simple, not as simple, too simple for my liking. So the idea is to get that file API and write it in Nim. What better way to learn a language than actually try to write something in it? So now, as I'm thinking, I did some search with Nim language. If we'll go back to Nim language, if we'll go to documentation, you'll see that they have, where is it? They have Nimble package directory. It's like, like your npm or NuGet packages. And there's not a lot here yet. It's a small language for now, with small community. But if we'll look for, let me start maybe again. This will be, file API will be mostly managing files. So if we'll go to documentation and, for example, go to the standard library, we should be able to easily find, things to work with files and whatnot. And that's all here. It's pretty easy to use with, can I search for file system or something? I'm sure it was something. Files, for example, files handling. It's all here. Moving a file, checking if it exists, removing. Other modules have, remove directory inside the, there's directories, standard package. It's all here. But the thing is that I want this file API service to be really reliable, and therefore I need to be able to test it properly. And for testing, those tests would need to keep creating images, keep creating files, removing them, moving, doing a lot of operations, and that would make those tests really, really slow. And the other thing is that sometimes those file operations, even though they are, you wait for them to finish and whatnot, sometimes operating system might just pretend that the file isn't there even though you finished creating it, because your tests are running so fast that even if you save the file, closed it, and start another test where you're checking if that file doesn't exist, it shows it still exists. So you will need to add delays to your tests. Suddenly you can't run them in parallel because they might be conflicting. You will need to have each test in a different directory. And it just becomes really, 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 it's not fun. So, for example, if I will be using Node.js, I could use a in-memory file system. And you could do the same in Go, because there are packages that basically allow you to use in-memory file system that pretends to be a file system. It stores stuff in memory. Therefore, you can have multiple separate file systems for each server, or for each test, you can have separate file system. And therefore, your tests will be really fast. Won't be wearing out your disk. Even SSDs wear out, so that why have additional cost? And you won't have conflicts that, wait, this folder is used by different tests or something. Every test is completely from scratch, and you don't have to wait for things to, being deleted, etc., etc. Basically cleaning up after your tests. You just remove that file system. You're done. And when it comes to NIM, unfortunately, while you search for a file or memory or something like that, I searched and I couldn't find anything that would provide that functionality of in-memory file system. Especially from the perspective of tests, where I want to have basically be able to create me file system like a real one, or create me one in memory, and I want to be able to operate on both, call exactly the same method on both, so my tests can run the same code as normal application would do. So I can test those methods, just instead of passing it real file system, I pass it the in-memory file system. So that leads me to the situation where I basically need to create a separate library for NIM or package, system of libraries. Yeah, they call them libraries. So I will need to create a library that basically is an abstraction of how you work with files. And that library would allow to create like little extension libraries, one for real file system, one for in-memory, and nothing stopping somebody to create another extension to that library that allows to, manage S3 files on S3 buckets, just as if you were working with normal files. And therefore your application, you can write an application that can, manage files no matter where they are. And I thought that could be a useful addition to the NIM community, if of course I will succeed. So yeah, the goal is to, maybe I'll write it down. Go learn NIM by creating a file system abstraction package with real file system and in-memory file system support. So that's the initial goal, to create that. Then create file API using NIM. So basically the first step would be, hey, while we're learning NIM, we can try to make that little library. And as we create that little library, which should be relatively simple, this should give us enough experience with the basics of the language, how to handle async stuff, how to iterate over things, how to maybe handle streams and things of that sort. And that should leave us to the point where we can go and actually try to write a web application that is using our library. So yeah, that's basically the goal. And for today, I thought that, after I presented basically the goal of what I want to do with this series, that's why I basically started my first ever stream, is just to share my journey through learning NIM and going through creating those libraries. And as there is a lot of content on NIM, I figured, hey, why not? Maybe somebody will be able to use it. I will, after I finish each stream, I'll also post it on YouTube. So later I'll add links to that. And yeah, that's basically what I would like to do. And you can join me in that journey. So let's see. Okay, so we can go in and basically start looking at NIM itself. So, like I mentioned, NIM is statically typed, compiled. In this case, they say systems programming language. I think it's more just general programming language. And it looks a bit like Python. I never touched add-on Modula, so I can't say anything about that. And what I like about it is that native dependency-free executables, so they're small, no virtual machines, so that's already some boxes checked out for me. It supports, all the major platforms, so I'm good with that. I only worry about Linux right now, but it wouldn't hurt if, whatever I write will work on Mac OS or Windows. That would be cool. Memory management is basically garbage collected, so I don't have to do crazy stuff like in C++, remembering to delete variables or Rust, or even things like in Zig where it's overly verbose. It's relatively modern. You have iterators, you have many nice fancy things. So we'll go over that. And what is very interesting about NIM is that the compiler doesn't compile the language itself directly into code. It first generates C or C++ or JavaScript, which is crazy. There's a difference that, whenever you're targeting C or C++ or JavaScript, between those two worlds, some features will work a little bit differently. But in my case, I only worry about C or C++. I don't want to write front ends in NIM right now, at least. So it compiles to C or C++, and because how the thing with C and C++ is that they can run basically anywhere. You can, you have compilers for C and C++ that can target pretty much anything. You can target your, normal Linux or Windows machine, but nothing is stopping you to target, for example, ESP32 microcontrollers. And because of that, because NIM actually first compiles to C or C++, there are actually libraries and project setups that allow you to target Arduinos. In this case, ESP32. I don't know if somebody's actually working with Arduino. That might be a little bit too low level. But that's the first thing. And the second thing is, because it just compiles to C, C++, it's just fast. It's really fast. In my case, as fast as you can go without, putting too much time into learning C, C++ to optimize things crazily. So, yep, that's something that makes me very happy as well. And it has powerful macro system. I looked a little bit at it, start getting a headache, but I guess if I would learn the language enough first, it could be very useful. And I also have some template system, which is much nicer. And you have the other nice thing that you have type inference. It's relatively smart to the point that you don't have to explicitly type everything. A lot will be figured out for you. So if you use TypeScript, for example, or even in some extent, if you use C# by using the var keyword, things are inferred for you, so you can write your code, and if you need to change something from int to long, it's often that you don't need to adjust too much. And just like in Python, statements are grouped by indentation. So let's look at their example. Let's see what they have here. So if we look at the example, import std/string format. That looks simple. It looks like we have a type declaration. Type person, that's an object. I presume this is similar to a class or JavaScript object. And it looks like we have two fields in there. Name, we can define as a string, and age, which is natural. Ensures the age is positive. So that's interesting. Usually we have just integer or float or something. Here we have actually, I presume it's an integer, just from 0 to up, because it's a natural, so we can't have negative ones. So instead of saying uint, we just have natural. And so that was our type definition. And then we do let people. So let, I presume, is like in JavaScript, where you can create a variable named people. And looks like it's an array of persons. So we can instantiate the person just by typing the name, and in parentheses we just provide the data, and that's it. We have an array of people, persons. And then we have a basic loop. So for person people, that's easy. And type save string interpolation evaluated at compile time. So we basically echo is like print line or write line, and we format it. Okay, so our quotations are preceded by FMT, so I guess that makes it special. And we just insert person from our person name and age, and they say it's type save string interpolation. So I guess if I would try to put something that's not convertible to string, it would complain. And because it's evaluated at compile time, you don't have that situation where your code gets to that point and needs to go through the whole string and then do the whole interpolation on the go. Your compiler will probably compile it to person.name plus is plus age plus years old, and therefore you will get optimized code rather than trying to parse the template during runtime. So I like that. Thanks to the iterator and yield constructs, iterators are easy to write as ordinary functions. They're compiled into inline loops. Oh, interesting. So we can, iterators is, I think in JavaScript it might be called generators. In C# there are enumerables. So basically it's a function that in this case looks like it takes two generic types. So we provide an A, which would be an array. Oh, interesting. In many languages, if you specify it that way, it would mean that it's a 2D array, but I think it means that you can specify the type of the index of array. That is very interesting. So we basically provide the thing with an array of t, and we just get t back. Interesting. Looks like just one t. Okay. Oh, because iterator means that if we'll give it a list, in this case it will start iterating over the list, and only when it's an odd number it returns that number. And that yield means that, hey, it's not an end of the function yet, or end, it's not return, it just returns that value. And whenever you request a next from that odd number, it will go back up. I need to go back to my loop and loops again until another one goes to yield until you basically run out of items in array, and then it finishes basically. So that means that you can use it in your for loop. So you can do for loop for odd and odd numbers, and you provide it with lists. So this will basically one by one be returning only the ones that are odd, and you can echo them. So that's very nice. This way you should be also able to do some fancy lazy loading things from databases where, let's say, you fetch in chunks and you return one by one, and whenever you next one, the odd numbers will take care of getting the data from the database. So you can just iterate over the records, even though in the background it might be, you know, prefetching them asynchronously or whatever. I presume that will be possible in this language. So use NIM's macro system to transform dense data-centric description of x86 instructions into lookup tables that are used by assemblers and JIT, just-in-time compilers. Interesting. So we create a macro, we get some data, return untyped. This is what I'm saying. It's basically, what do I say? Macros are interesting, but yeah, I guess look at the table of some instructions. Great. I'll ignore that. I don't want to go to level of macros right now, nor assembler. That's not what I'm concerned about now. A simple example. Let's look at if-else case switch. So we have, previously we had let, and now we have var. That's interesting. So we have variable conditional 42. So I guess it automatically figures out, okay, this is a number, probably integer. And if conditional is less than 0, we say this. Else if, so this is basically Python. I didn't do a lot in Python. I did some years ago. But okay, that looks decent. Nothing crazy here. Simple, I like that. And ternary, awesome. Oh, and if conditional is this, then true, else that. So ternary is, I like it, instead of just question mark and colon, you just have if and else. That's simple. Why not? Then we have another, and oh, cool. So the classic thing is with if else is that, you know, it's a statement that does something. While here it's used as an expression. So we say that another equals, and then basically this whole thing is being evaluated and shoved into another. So basically here we can use if, elif, and else as an expression, just like a ternary expression is. So that's really cool. I wonder what else can be used as an expression. In case switch, we create a letter, and we have single quotes versus double quotes. So usually single quote means that it's not a string, it's a character. So we have a character letter, and it's a switch statement. Here just they call it case letter of A. So if it's A, do this, of B, comma C. So we have basically OR. Interesting. I wonder if you can describe something more complex like this and that. Interesting. I wonder what the pattern matching capabilities are here. Okay, looks like a range. So the letter is between D and H. So looks like we can convert the character to a number, like an ASCII character to a number. And between this and that. Why not? That's cool. And of course, else. So your default case. Cool, I like that. That's simple. Basic math. Okay, so we have some math package. Okay, this is all normal. Division. Oh, that's interesting. So if you have integers and divide them with normal slash, you will get a float, some kind of floating point. While if you want division on integers, you need to use div. Power is with, I have no idea what that symbol is. I just use it for power actually. We have modulo. Okay, all this stuff, p and tau, so we have some constant declared, and our functions from math. So that's all normal. Greatest common divisor, cool. So we have lots of goodies there. I'm not good with math, but I guess there's... Okay, lots of good stuff. That's nice. Here's a range. Oh, that's very interesting. When you clamp the number of 1.4, you can actually use a range from this to that. And looks like it's inclusive, so it includes the 1.0. Okay. That's cool. I like it. Next we have string operations. Just check the stream. I'm not used to checking on things here. All right. So continuing. String operations. Okay, so we use ampersand for concatenating strings. Okay. Strip is to trim things. You can parse it to integer. Interesting, so you get a number, dot, parse to int. So you have basically something that's a string. You have some operations declared on that string. Parse floats, hexen, all that stuff, boolean and such. You have repeat. That's nice. You can check if it starts with something, if it ends with something. Okay. And you can join an array of strings. That's cool. It's all simple. I wonder if you can define more, like provide it with some kind of separator or whatever we call it, delimiter, separator, let's say. You can find which index the C is at. You can count specific substring. Cool. Normalize. That's interesting. I wonder what that's defined as. And what else? We can split things with a separator. Oh, that's cool. We can center and indent. I guess when you're making some terminal, like CLIs or something, that would be handy. And an indent. Cool. I like it. Forward and tokenize. Okay, so I guess this will split it into words, just one simple function. I like that those things are already defined and, you know, taken care of for different edge cases for you. One less thing to have to write on your own. And what else? We have scan tuple. Okay, year, month, and day. So we're basically destructuring a tuple, and by scan tuple, that's interesting. So I guess it extracts values from here depending on some kind of expression. Okay. That might be very handy actually. Cool. What else is there? Comprehensions. Comprehensions. So we can import multiple things, multiple libraries from the standard library. Okay, I like that. Sugar. So variable collect new string, but new string, we don't have new string. New sequence. For items, and that @ symbol is interesting here. Oh, this is a colon. Okay, so... Oh. I don't know what... Oh, I think I know what is happening here. So... I presume this is maybe a constructor for a new sequence or something. Sequence would be like a list, I presume. So we can then use collect, and what it will like run this code. So this would be like your lambda in here. Usually, like arrow function or something. But instead you just indent it because you start a block here. And so basically we take this, let's call it a sequence. I presume that's what add is in front. So it's not an array, it's a sequence. And for each item we double it. And as this doesn't have any return or something, I guess that automatically returns it. Just like you have in Rust. And therefore, that will basically collect it and add each element to that new sequence. Okay. That's definitely something you would need to get used to, but simple enough. Yeah, exactly. So it looks like that's a sequence of all those values doubled. Makes sense. What else do we have here? Again, collect table and key value. Wait, what? For key value and not sure about that here. Maybe that's a separator here. I'm not sure. Possibly we just... So it looks like we're getting a sequence of those three numbers. We iterate over them, but we get the key as an index, 0, 1, 2, and value, which would be 0, 5, 9. And then we basically convert it into pairs of that key and value divided by 2. So in this case, because we're using the division for integers, they will stay integers, so it will be probably 0 and 2 and 4. And therefore, yes, we have index 0 and 2 and 4. Yep, and not sure what that is exactly, because then we're calling to table for some reason. So, not sure. So I guess this becomes a table while this is... I'm not sure what this is. Okay, we also can do, again, this collect thing and a hash set for item. And here we just make a list of elements, unless that plus symbol, again, means something else. I don't know, a little bit confusing. I guess we'll get to that. And then we have to sequence 1 to 15 and map it. Oh, okay. So if it's divisible by 15, we have fizzbuzz. If the item in the sequence is divisible by 5, we do this, 3 fizz. And if not, just leave the element as it was, whatever that $sign is. Maybe converts it to string, because we're returning strings here while we, as input, we're getting numbers. So I guess this will be interesting to just put a $sign to convert something to the string. Okay, and then we join with a separator. Okay, and remove all the white space. Yep, I really like that. You can map it and can create sequence of a range. Awesome. I like those little goodies. Okay, so that's basically introduction to Nim. So let's see if there is some tutorials or something. Go to documentation. Learn nim in 5 minutes. There we go. Okay. So I don't think at this point I will be writing any code. I just need to continue going through documentation and basically see what is happening. So learn nim in 5 minutes apparently. So we can make it dark for everyone to just have it easy on their eyes. Nim, formerly Nimrod, is a statically typed imperative programming language that gives the programmer power without compromises on runtime efficiency. Nim is efficient, expressive, and elegant. Okay, so we start with the most useful thing, which is a single line comment. Start with a hash, just like in Python, I believe. So multi-line comment can be started with hash and square bracket, and close with that. And multi-line comments can be nested. Okay, I like that too, because sometimes, let's say you had a comment, a block of code that you had used a multi-line comment block in there. You can surround it, and this way you won't have issues where suddenly this here ended your comment and you have some mess. I like that. Discard. Interesting. And then we have 3 quotes, so I guess this is a multi-line. Yeah, it can also work as a multi-line comment or for unparsable broken code. I guess because it's discarded. So I guess they're showing us 2 features here. First one is discard, as you can discard something. And a feature where you can write multi-line strings. I don't think it's just a comment, it's a string. But in case it's discarded, so it's a comment. Okay. So I guess the compiler is smart enough to just completely ignore that. Okay. Declare and assign variables with or without type annotations. Okay, so we declare a variable with var. We declare a letter, so it's a character. And yes, single quotes for a character. And then we have language, which is ampersand I am. So I guess, these are 2 strings because they have double quotes and they're concatenated into a single nim. Okay. And length is an integer. And looks like we have a built-in function for just getting a length of something. So we can get a length of a string, which here I presume will return 3. Then we have float that we can specify, and we don't have to assign any values. I presume it will get assigned default value, which will be 0 in here. And then we have truth, which is boolean. Cool. Simple. Okay, let. Use let to declare and bind variables once. Oh, okay. So here legs is immutable because we declared this as let and we gave it a value. And after that, you can change it no more. Okay. And here underscores are ignored, so you can just easily make large numbers readable. And this, I presume, will be float. Okay, so I like that distinction between let and var. Var is something mutable that you can change, I presume. Well, let is something that you can assign once, and that's it. And then you have constant. So constants are computed at compile time. This provides performance and is useful in compile time expressions. Okay, so constant are only at compile time. And again, the type is basically the compiler figures out the type on its own. also for constants. That's awesome. So we basically have constants as values that you assign once, but then the value needs to be needed at compilation time, so before your code runs. Then we have let, which seems like is also assigned once, but you can probably run some code during runtime here. So this will be assigned during runtime, and let's say you create an object and it needs to assign that. It takes it from the configuration file, and after that, the rest of your code won't be able to reassign it. Therefore, it will stay the same. So that's really nice. It makes it clear that, hey, this shouldn't change. Well, var is immutable, so it can change. Cool, I like it. When compile bad code. When is a compile time? If. Okay. This error will never be compiled. Constant values must be known at compile time. So I see. So this is like in C#, you can have like pragma if statement, where you can decide if code will be compiled or not. So this is similar. This will be basically calculated only if compile bad code is true. So here we have a constant that's being defined as false. And because it's a constant, it was evaluated during compilation time. And therefore, this code just won't even get compiled. So there will be no errors because you won't be able to, because this wouldn't work, because you can't, legs is, one-time assignment, so you can't reassign it. And we're trying to define a constant input by using readline, and readline is basically waiting for user input, so this is not something that's known during compile time either. Okay, I like that. Simple. And discard 1 is larger than 2. The compiler will complain if the result of an expression is unused. Discard bypasses. Okay, so basically if we have 1 larger than 2, that little thing returns a value, true or false. In this case, it'll be false. But this value isn't used anywhere, isn't assigned anywhere, so the compiler will be like, something's not right here, and it can discard it. Okay, that's straightforward. I like it so far. What else do we have? Data structures. We have tuples. So basically, we can declare a variable child. We can explicitly say that it's a tuple and give it 2 named values with types. Tuples have both field names. Okay. And order. Okay. So yeah, that makes sense. Tuples are ordered because if you would use tuples in C# or in JavaScript, I think JavaScript has tuples. Maybe TypeScript has. I don't remember. Go has tuples. Then you would address them. You could address them by saying child and then the square brackets and 0, which is index of the property inside. But here you can get them names. That's interesting. So we have child. We are overriding it. Name and age, so you can assign all at once with the literal. Okay, so basically when you want to override tuple, you can assign values. You just need to make sure that it's in normal parentheses. It's just the way how you would create tuples in other languages. Or you can just assign specific values to them, and you can use dot notation. So that's awesome. That's like at this point, this acts like a little object, because you can refer to things by name. I like it. Then we have sequences. So we can make a sequence drinks. It's a sequence of strings. And yes, then for sequence. So we have that add symbol, and then in square brackets. This is the sequence literal, okay? So we assign drinks to the here. We water, juice, and chocolate. Okay, 3 strings. And then we can add something to the sequence. Okay, so sequences are basically like mutable lists that can grow in this case. So it's not like an array where you would specify, you know, okay, there are 3 elements and you can't add anything, you can just assign within those 3 elements. So I like that. We have sequences. We can iterate over them. Oh no, wait, that's not if. If milk is inside drinks. Okay, so you can check for contains. That's cool. And if we have milk, we say we have milk and here we calculate the, oh, interesting. Somewhere here, we're using length before, while here, like a you know, overall global function, while here we're saying drinks dot length. I wonder if they're interchangeable and you can do both. Interesting. So, and other drinks. So I guess echo can take just different, however many arguments there are, one by one, and we'll concatenate them on its own. We don't have to use ampersands here. Okay, and it automatically converts integers to strings. All right. And then we say my drink, and we get a specific index, number 2. So it'll be 0, 1, 2. So he wants chocolate. Okay, my drink is chocolate. Cool. What else? Defining types. Defining your own types puts the compiler to work for you. It's what makes static typing powerful and useful. So we can declare type. And I guess you can define several types at once. So first we define type name, which is a string. So a type alias. Okay. Type alias gives you a new type that is interchangeable with the old type, but is more descriptive. Okay, so basically instead of saying that something is of type string or of type int, we can now say that it's of type name and age, and everything will still work the same. So if you pass it to a function that expects, for example, a string, and you will give it something of that type name, it'll still work because underneath is a string. Okay, makes sense. Person, and we define it as a tuple. So here we define a shape. So basically whenever we say it's of a type person, it will basically expect a tuple. Okay. And you can also define tuple. Instead of those square brackets, you can just go top down. Just make sure indent. Okay, I like it. Simple. Easy to read. And we create variable, and it's a person. Yes, we saw that assignment already. New age. Integer is 18. Better to use age than int. Yeah, you could, I guess, change it to and. So I'm understanding this is written as if you could run it yourself and read it in there. So let's try that. Can I go back? Documentation. Official NIM playground. There we go. So if I'll grab all this code, there's no copy. Okay, and we paste it here. Oh wow, okay, this is gonna be painful in the stream. Collision targets, C or C++, doesn't matter. Okay, gonna be a little bit better. I hope that's large enough. All right. So let's get back to things. Let's just try to run it and see what happens. It's thinking. Okay. We have milk and 3 other drinks. Read. Make good books lately and unhandled exception. Okay, so we'll get there. So we basically, when we executed it, we had all those variables, we went through that. This didn't trigger any errors. If I'll change it back then to true and run it now, it should probably... Legs cannot be assigned to and something. So yes, this instantly here tried to execute and complains that we can't assign anything to legs. All right. If I would comment it out by putting this in front and run it, it would probably complain about that because we cannot evaluate at compile time. Perfect. Okay. That stays. We just make it false. And we can run it again. And all that should be discarded. Okay. So through that data structures, we went through this. And we echo that we have milk and 3 other drinks. That I was here. That's good. And we could probably add some like echo my drink. And we could say my drink is and comma and run it, and that should say that my drink is chocolate. Because chocolate was 2, right? Yes, my drink is chocolate. So we know for sure that sequences are indexed from 0. Cool. We had our tuples. Or we're defining them. We went through that. Let's just get back to our types. And we said that we have this and a new age. It's integer 18. So it would be better to use age. So if we would use age, it should still work normally. Oh wait, look, here we have an example. So we declared new age as integer with a value of 18. And here we're basically taking our person. Our person is defined that it's expecting age, and age is an integer, alias for an integer. That means that, also works because and an age are synonyms. Yeah, they're basically, the same thing. Okay, I like it. Then we define type cache. It's a distinct int. Distinct makes a new type incompatible with its base type. Oh, I see. So even though the cache is integer and description is string, you wouldn't be able to assign normal integers. So we have var money cache is 100.cache. So .cache converts the integer into our type. I see. The same thing with string. We have a string, but we still need to convert it to that description type. Oh, that is really nice, because it's often that you want to that's, let's say you're working on some functionality that you have various number of... First thing that comes to my mind is, for example, units. Let's say that you want to have units like like for example pounds and kilograms and let's go feet and inches. I mean feet and inches and centimeters, right? So you can represent all of them as integer or maybe floats if you want. But when you make them distinct, so let's say I would say that there's something like a foot, and let's do inch, and that's distinct float. And then we decide centimeter. is distinct float. Okay, we have those two units. Both are describing length. So you can say that, let's say, what do we have? New variable. Okay, new variable, and let's say that would be the monitor diagonal. And we can say that it's in inches. And then we can say that it's, let's say, I don't know, 30. If I would say it's 30. This should complain because we're trying to put integer into float. So let's see that. Error, undercurrent, undefined, distinct. Run again. So now we have small error, those errors are small. Error, type mismatch, got integer literal, which is 30 for 30, but expected inch equals distinct float. So if we'll make it on 0, which will be a float, right? We run it, it should complain that it's a float. Yeah, float 64. Oh, interesting. So it defaults to float 64. But expected this. So I would need to say dot inch. Right? And we run it. And it's happy. No problem. Okay. But then let's say we have another variable and we define it as what could it be? Phone diagonal. Okay. And we say that it's centimeter. And this way we would need to define that, hey, this is whatever that will be. 16 dot centimeter. So these I don't know if that's gonna work. It worked. Even though we have an integer, we were able to, and this is defined as float, so we're able to change into that float. Okay, that's fine. But that means that later I can't make it, for example, where phone diagonal is, let's say, a phone grew to the size of a monitor, which is monitor diagonal. You can't say that, so that therefore you shouldn't be able to mix those two. Yeah, mismatch of inches and centimeters. So you won't have, a stupid mistake that, oh wait, this was supposed to be centimeters instead of inches, because you need to explicitly say, I presume dot centimeter. If I would say that, I presume that this will allow inch to just turn into centimeter. And now it's fine, even though, here you explicitly need to convert one into the other. That means that you need to be aware that you actually made a conversion. And this is something that can prevent some really nice, pretty nasty problems. Okay, I like that. So let's just ignore that and see what's later. So yes, we can say money is cash, description is description, and compile bad code. So we had that age, which was supposed to be age, even though it's an integer behind it. We can't assign money to it because money is, cash is distinct. Yes. And the same thing with strings, because description is distinct of string, therefore they won't work. Awesome. More types and data structures. Enumerations allow a type to have one of a limited number of values. Okay, so we have color, and that's an enum of C red, C blue, and C green. Okay, and then we have another one, which is direction, And we can just, you know, instead of making them one line, we can just present them this way, which I sometimes would prefer, I guess. Okay, it's interesting. So the color, they all start with C, while direction, they all start with D. Interesting. And then we create a variable, orient, D north. Oh, okay, so you don't even need to say that it's a direction dot north, just say D north. That's probably why they prefix everything with the D like direction or C like color. Okay. Well, pixel is C the green. Okay. Cool. So that's again the compiler inferred that hey, you probably mean that. I like it. And enums are usually an ordinal type. Ordinal sounds like something that will be ordered, as in counted. So therefore, you can compare the north to the east. So I guess this is 0, 1, 2. So this will be false. If I would do echo, the north is larger than the east. And let's see if we're gonna get result, and it should be false. Yes, the north larger than the east, false. Perfect. Subranges specify a limited valid range. So we have type, die faces, it's a range from 1 to 20. Only an int from 1 to 20 is a valid value. Oh, that's really nice. That is really nice. So you won't be able to pass in like too large or too small value. I like that. And my role is die faces 13. If we would try to give it 23, then it will complain that wait, you can't assign 23 to the range of 1 to 20. I like that. Okay, so we had sequences. Now we can look at arrays. So arrays type roll counter is an array. Arrays are fixed length and indexed by an ordinal type. Oh, I see. So indexes are not just integer, like pretty much everywhere else where whatever other language are used. Here you can actually specify that, hey, so we have already an array of from 1 to 20, and that's it. You can put direction, which was an enum of 4 values. That is interesting. Or again, you can say truths from 42 to 44. So I guess we'll have 3 elements. So far, those values were inclusive. Everywhere we had this thing here. The counter is a roll counter. So, okay, we have an array of those. Okay. So, direction is possible is truths. Okay, so we basically create a variables from that. Possible, which is truths. We have 3 elements, so we can say false, false, false. So we'll be created with that. Okay, that means that we basically, the index 42 is false, index 43 is false, and index 44 is false. And all the other indexes don't exist. That is a very interesting approach to arrays. Possible 42 is true. So yeah, we can override it. What happens if I'll try to echo it? Possible. And we just do this. I will display it. Oh, just upset. True, false, false. Perfect. And if we would try to do possible and say index 0, it should just complain that it's not possible because it's not between 42 and 44. Yes, index 0, not in 42, 44. I like it. Prints the whole range for you. What if I'll do directions 0 or like directions 100 because there were only a few directions? How will that print the values? Type mismatch. Okay, one has their name and one is integer. Okay. I like it. Okay, works, makes sense. I like it. Direction, and here we can say the north, it's that, while the west is that. Okay, so we can assign that. That's a nice name because sometimes you need to create those small types, like let's say you're working on a game and you need to store just some direction, a single, like an array of possible directions or something, or other possible values. And let's say you have a little tile, and usually in games, and from that tile you can go in each direction and diagonals, so you have 8 possible directions to go, and you could specify what is the cost to go in each direction. So you basically can make an array of your directions with a value of your cost, which is, I don't know, integer or something. And this way it'll be made sure that you don't specify it by 1, 2, or 3. You need to specify by that specific enum, and the compiler will stop you from doing something wrong, from introducing a bug or something. That's awesome. So what's next? My roll is 13. Counter my roll increased by 1 and increased by 1. So where was the counter? Okay, counter is of that. And we have my roll, which is 13. So we can take the index of 13 and increase it. So die faces was just a range of integers. So it's fine to get that number 13, the index 13, and just increase it twice. Okay. So basically added to our counter of rolls that, hey, you rolled 13 and 13 again. Okay, somebody has bad luck here. Okay, and another array, and this looks like you just create an array of just 3 strings. Default index starts at 0. And looks like I'm running through camera batteries like crazy. So just give me a moment. Camera's back. I guess I'll need to get myself one of those dummy batteries. Okay, looks like we went through the arrays and we have just a little bit more left. We still have whole half an hour. Okay, so we're good on that. So let's see, more data structures are available, including tables. So we had, oh, okay, so, oh, I see. So we had tuples, we had sequences. Sequences can grow and always start at 0 and are indexed with integer. Then we have arrays, which can have custom index, and I presume they have to have fixed size because we haven't had an example of adding new values to a to an array. And then tables. So tables, we saw one at some point, I think. So I presume tables are multi-dimensional arrays. Interesting. Sets, okay, I like that. So we can just make everything unique. Lists. Are lists different from sequences? Queues and bit trees and all that stuff. Okay, so we basically have plenty more that's already made. Cool. So we can go to IO and control flow. Case read line. So echo, reading good books lately, and it's basically waiting. Okay, so it's waiting for user to input something, and we basically do a switch case on that. If it's no or no, so again we can put two variants here. Go to Echo Library, and if yes, again both cases, carrying on then. And else, that's great, I assume. So if we put something else, then yes or no. Okay, that makes sense. And when we run it, I guess here, this little thing doesn't really work because because we can't put stuff in. But if we would just say no and run, will the compiler be angry about that we're doing a case on? Okay, I'm thinking of go to your local library. Okay, so yep, that works. Cool. Then we have while, if, continue, break. So that's interesting. We can import somewhere in the middle of the file too. We don't have to import, everything at the top. I like it. So we import string utilities. I'm thinking of a number between 42 and 43. Guess which? So we of course all know which number. It's 42. So we assign a number. We can't reassign it. We create two variables. Raw guess, which is a string, and integer string. Okay, so basically while guess is not a number, so when guess is not 42, we take the raw guess from the read line, which in this case will crash, so let's say it's 41. If raw guess is nothing, then continue, so basically go back and ask again. And then we convert that string.parseInt raw guess. Okay, so that's our string utilities, where we can parse that string into integer. And if guess is 1001, nope. And we stop it, just quit. And if it's large, it's too high. If it's not, too low. And If it's good, then yeah. Okay, that's simple. So we have simple while loop where we can completely exit out of it, or we can continue on to just skip. Okay, that's simple. We'll just put 42 here and we'll instantly get IHA. Okay. Iteration. So we can iterate with a for loop. So I an element. Okay, so we can take a array, take an array of 3 strings and iterate over them with an index. And basically elements. So yes is at index something. Okay, so if we run it, we should see it right under yeehaw. Mismatch is with the string. Oh, my bad. Okay, yeah. Yes is at index 0. No is at index 1, maybe so is at index 2. Alright. So that was simple. And for KV and items, and we give it sequence of tuples. Okay, so we have tuple, person, you, and power, and me, and power. So we basically have a sequence of those. That's why we have that at symbol, and square brackets is the sequence of 2 tuples. And I guess you can, there's items, it basically returns pairs of key and value. So this is 0 and this is 1. So this should echo 1 by 1. Value will be 100. Yes, down here we have 100 and 900. Yep, that's it. So basically return those tuples as K and V, because K is at index 0 of person and the other one the other. Okay, that makes sense. You can iterate over those. And then we have string multi-line row string. We saw that before. And looks like you can just start from next line to have everything formatted nicely. All right. And you are not supposed to have something like this. I guess there's no indentation here. Yeah, something like that probably wouldn't go through. It will probably return space and something. And then for each line, and split lines, so we split that string into lines. For each line, we just print it out. So we have an example string to play with. So if I'll indent, looks like indents with spaces, even though this would be, let's call it Python-like. If we run it, we should see the result too. Yeah, they got indented. And it looks like it added an extra line after that. That was empty. Just those 2 spaces. Yeah, 1 and 2. Okay. So if we get back here, it'll be back to normal. Alright, makes sense to print those lines. So then for IC in my index and letter for JN or just letters. Okay, so in this case we iterate over each letter in the string and we can check if it divides okay. So basically we're checking if that index is divisible by 2. If it is, we just skip it. So we print every second letter. And so basically if we skip, We don't need to make a new indentation or anything. We just, if it's one word, I guess we can just do bam. That's the compactive form. Then we have else if the character is the capital X, we absolutely stop the whole thing. And if not, we just print it. So we should have the A skipped and printed. Space skipped, this printed. And we just did all that. So if we would do, for example, capital X, that little X wouldn't be printed anymore. It would just stop after that. And yes, it's printed N, and then angle bracket, and nothing else because it skipped the E, and then X countered and it just broke it. Cool. Okay, we're getting to finally good stuff. Procedures. We define type a answer to be an enum, either yes or no. So we can define a procedure. So I presume it's just like function anywhere else. I believe, yeah, I started learning programming like then with what is it, Object Pascal or like Delphi Pascal. And there was distinction between procedures and functions. Maybe this is the same here. So we have a procedure that's named ask, and we give it a question, which is a string, and it should return an answer, which is either yes or no. So we basically say our question and add yes or no. And then we're just waiting for an answer. So we read the line. If it's yes, any of those, it'll return yes. If any of those, will no. And if not, it will basically start over and wait for, say please be clear and wait forever. So you actually can't escape it. Okay, so we have simple procedure that will return either yes or no. And then we have add sugar, another procedure that takes an integer and looks like it's a default. Default amount is 2 and returns nothing. There's nothing there. It's interesting that those procedures, they end with equals and then you have your contents. Okay, I like it. That equals is funny. So here we assert that amount is this and that. Crazy sugar. So if amount is larger than 0. Okay, and amount is less than 9,000. We just call it crazy sugar. 4 and 1 to amount echo sugar. Okay, so this basically should always say, unless of course it's over 9,000 or less than 0, it will say crazy sugar, and then basically print it out however many times are left. By default 2, or you would say 30, it will show more. So would you like sugar in your tea? No, if you say yes, so we call that procedure, it should return the answer so we can case over it, switch over it. So if it's yes, we do add sugar 3, and that should return crazy sugar, sugar. And if it's no, I'll do take a little and we add sugar just 2. So we create the sugar. Okay. No need for else here. Only yes and no are possible. Okay, so it looks like compiler is checking if there are any skipped cases. Okay, that's good. So let's try it. We don't have the read line available. So let's assume that it's always yes for now. And it should execute this. T, oh, it prints sugar 1 to 3. Okay. Maybe we'll show crazy sugar if it's anything else. Okay, so if we'll say it's -3, run it, it will just break, right? And we have that. I guess this is just a note for us. Okay. Alrighty. So we just have that. If we'll do 300 or 30, it will just go nuts. Okay, makes sense. So then we have FFI. Because nim compiles to C, FFI is easy. Oh, I presume that's the when we have compatibility with C languages. I forgot what was FFI, like foreign function interface or something like that. But it looks like we have a procedure, the string compare, and we give it to C string. So that's interesting. And we return cint. So I guess that's the compatibility types between string and C version of the string, and we have C version of int. And that is interesting. Import C as string compare and node CL. Okay, I don't care about that right now. Okay, so that was the first learn nim in 5 minutes. I personally really liked it. That was really simple. So additionally, nim separates itself from its peers with metaprogramming, performance, and compile time features. And you can read more. Okay, that was nice and short. So we're basically have only 10 more minutes. And in basics tutorial, what is this? It goes through everything here. Okay, that's a long tutorial. Let's see. I'll read the introduction and maybe we can continue. When we run out of time, we'll continue with the next stream, which I don't think will be tomorrow, but maybe after tomorrow on Wednesday. We'll see. I will add it to the schedule. And like I mentioned before, I will add all those videos, upload them to YouTube, after which I will add the link to YouTube on my Twitch profile, so it should be easy to reference and go back to things that maybe were lost at some point. So, in basics, nim is a relatively new programming language which allows users to write easy to read high performance code. But if you are reading this nim tutorial, the chances are that you already know about nim. So we have tutorial as a PDF too. It's a work in progress. Okay, who's it for? People with no or minimal previous programming experience. Okay, people with some programming experience, that's good. People who want to explore nim for the first time, starting from scratch. So in my case, it will be that. So that's good. Who is this not for? People with lots of programming experience. Other more advanced tutorials might suit you better. People experienced in nim, feel free to... Okay. I mean, I have lots of experience with other programming languages, but for the sake of here, the stream, I guess we can go through this basic tutorial and just make sure that we actually understand everything correctly. Because what I found often is that those simple tutorials, they either skip over things that creators or maintainers of the language assume that is known, but because you had experience maybe with programming language A, B, and C, while the creators of the programming language would, have experience maybe with some other languages, they're assuming that you know one thing, while some people know the other thing, and you start to assume things that are not really true, and then you find out later in edge cases, scratching your head, what is going on? Why isn't it working? And it's because there was some little edge case detail that wasn't explained in that tutorial. So I think going through the basics from scratch, I guess it would be beneficial, even though it'll be fast. We can go through it. So basic programming and the NIM syntax, so you can have easier time following other tutorials and will explore further by yourself. Instead of just reading, it will be best if you try the stuff by yourself, modify the examples, think of some skills on your own. We'll check that out. The exercises at the end of some chapters should be non-negotiable. Don't skip them. All right. And there's more stuff here. Cool. Installation. Installing NIM. NIM has already made distributions for all 3 major operating systems, and there are several options when it comes to installing NIM. You can follow the official installation procedure to install the latest stable version, or you can use a tool called Choose NIM, which enables you to easily switch between the stable and the latest development version, if you're interested in the latest features and bug fixes. Okay, let's check out Choose NIM. I haven't heard about that before. Okay, last update 2 years ago. Maybe it's okay. 662 stars. Okay. Installs new programming language. Provide easy to install. Typical usage. Choose NIM stable. And install that. Switch to NIM 1.0. Okay, that's how you just select stable. Update to latest stable. Okay. Choose NIM show. That's what's selected. And other versions that are available. Okay. You can install on Windows, on Unix, you can just do that. Okay. All right. We might check it out at some point, but we can also look at the official installation procedure. In my case, I'll want to do it on Unix because I'll be working with Docker containers, and it'll be a little bit easier there. So again, choose NIM as an installer. Okay, or manual installation with those. So I believe I did it with that way. Let me just check if I'm right. Okay, so I'm on the what do you call it? WSL2 on Windows. And do we have Choose NIM? Yes, so I guess I installed it through Choose NIM 016. So I should be able to do Choose NIM show, and it will show me that I have NIM version 2.02 installed. And I should do Choose NIM update stable, I guess. Already up to date. Okay. So, I mean, all it is, you just run this command and you're done. So that was that. I did that before. You might just need to configure the path environment. That's, if you're using Linux, you should be familiar with that. And for Windows, I guess it will take care of itself. So I believe I can do nim version or something like that. Yes, nim compiler version. So we have it all installed. So that's good. So we can skip the installation. Whichever way you choose, just follow the installation procedure. If you're using Linux, they're hypothesized that your distribution has nim in the package manager. In my case, on Ubuntu, for some reason, I mean, it worked. It just had an older version of nim 1 something, while relatively recently we had the nim 2.0 was released, so I'm using the newest. Okay, we'll use the stable version. So originally it was written for that and should work with any newer version, including nim 1.0. Well, we have 2.0 now, so I guess, yeah. Additional tools. You can write nim code in any text editor and then compile and run it from the terminal. If you want syntax highlighting, the code completion and code completion, there are plugins for popular code editors which provide these features. Most of nim users prefer the VS Code editor with the nim extension, which provides syntax highlighting and code completion, and the Code Runner extension for quick compiling and running. So with VS Code, I actually went and installed nim, because when you search for nim, you can see that the most popular package that has 89k downloads is nim by Konstantin Zaitsev, but I recall that the latest release was in 2020, while there's nimlang.org, which I have installed. It's a nim language support for Visual Studio Code. It was updated last few days ago. And when we go here, where's the link to repository? I go to the repository. You can see that this is maintained by the nim language maintainers, so I guess that's the official plugin now. So basically, when using VS Code, make sure that you install nim.lang.org by nimlang, and this way you'll have the most up-to-date extension. So that's that. And so let's go back. The author personally uses NeoVim editor. I would like to learn that one day, but I don't know. I don't think I have enough patience and time right now. Okay, so testing the installation. To check the installation was successful, we'll write a program which is traditionally used as an introductory example. Hello world. Okay, so let me delete the old stuff here, because I tried if it works. Go. So let's do hello.nim. So in a new file called hello-world.nim, we need to write just one line. Echo hello world. Echo hello which. Okay, and we can save it. Phrase you want to print must follow echo command and must be enclosed in double quotes. First, we need to compile our program and then run it to see if it works as expected. Open your terminal in the same directory where your file is, and we compile our program typing nim c hello world. So in our case, we go nim c, I presume that's for compile, hello.nim. Enter, and it compiled. Looks like we have hello here, so let's do ls we have, hello, an executable. That's awesome. 95 kilobytes. Wow. That's a lot for that, but less than many other places. Okay, after a successful compilation, we can run our program. Okay, so we just do dash hello, and we have hello Twitch. Awesome. All right, so we go through our hello world. Let's just finish reading here. If you're using VS Code with the Code Runner extension mentioned before, you just have to press Ctrl Alt N, and your file will be compiled and run. So let's try the Code Runner. Code Runner. Never used it before. I'm not really used to Visual Studio Code that much. I'm usually the JetBrains guy. Okay. What was the shortcut? Ctrl Alt N. Okay. Verbose to 0, hints off, and run. Okay, so that's more advanced command. Cool. And run. Done. Awesome. Whichever way you choose to run the program after a brief moment. Yeah, an output window. You should see the hello world. Congratulations, you have successfully run your first NIM program. Now you know how to print some stuff on a screen using the echo command, compile our program, and run it. We can now start to explore the basic elements, which will help us write simple NIM programs. All right. So after that, we'll learn about naming and all the details of that. So that will be probably on Wednesday. So thank you for watching, and I guess see you next time.